Hello, hello, Rubyist. Thank you for coming, Fukuoka. Coming to Fukuoka from everywhere in the world. I'm going to talk about the fastest way to bootstrap Ruby on Rails. At first, I'm going to introduce myself. I am Kondo Uchio. I am one of the local organizers at this RubyKaigi 2019. Also a chair of Cloud Native Days Fukuoka. I have written some books and I have written some Ruby open source projects. I like Ruby. Also, I like Linux containers. And I am now living in and working in Fukuoka. My company GM Paperboard has Fukuoka office in Tenjin. I live in Yakuin, where is Fukuoka's best coffee town. Please visit Yakuin. I also hold Fukuoka RB with Nagachika and Jim Rock. Me and Nagachika and Jim Rock is the talker of today's RubyKaigi. And many helpers and organizers are from Fukuoka RB. We welcome Rubyists. And this is my this is my product. Haconiwa is MRuby on container. All DSL about container can be written in Ruby DSL. Then I'm going to show about Japanese script. A little speak in Japanese. 日本語の方が得意な皆さんのために日本語のスクリプトを今日用意しています。私の最新のツイート、RubyKaigiでツイートしツイートか、こちらの QR コードでリストを眺めながら話すと、少し Rubyist に馴染みがない話題なので、理解しやすいかもしれません。Okay. So, at first, let's introduce you to CRIU. This is CRIU, pronounced like screwed CRIU. Okay. I am one. By the way, I am one patch contributor of CRIU core, and I have read many parts of CRIU's code, which is written almost all in C language. Then the fastest way is using this tool. Indeed, this fastest way is this fastest way is effective for Ruby on Rails and Sinatra and Hanami, and Padrino, and many Ruby framework. And it is also effective for other script languages such as Python, Node.js, Elixir, and so on. For example, do you know Django? Please raise hands. Oh, okay, yes. Django is so famous via Hello Ruby. Have you read Hello Ruby? Written by Linda Rickhouse. Django is one of the characters in the book. And Django is also well known as one of Python's major web application frameworks. Indeed, this CRIU is very effective to make Django's bootstrap fast. So I ask again, have you heard about CRIU? Please raise hands. Oh, very, okay. It's そういうもんです。はい。And okay, next question is, have you heard about processes? Do you know processes? Please raise hand. Okay. I think because you are using computers. So processes are the very basic concept on which an operation system executes tasks or programs. And CRIU is a tool for Linux to dump processed information into an image and restore processes from a dumped image. CRIU stands for, indeed, checkpoint and restore in user space. CRIU is one of the tools for processes, but it can be applied to containers, special processes, to make checkpoint and restoration. By the way, internally, CRIU is using kernel functionalities such as block file systems, C groups, TCP checkpoint after kernel 3.5, and many system codes to get process information and then create an image. And here, CRIU is useful. Using CRIU, we can do migration and making apps fast in Bootstrap. At first, I will describe about migration example. When you want to reboot host VM, having a few containers like Docker or LC daemon, you do not want to restart containers for some reason, like mission critical applications. It's time to use CRIU. Using CRIU, you can dump containers into image on the first and then after you copy these image dumps to another host, you can restore dumped containers from them in new host. The container contents are the same. So this is rebootless migration. And by the way, when you manage VMs on KVM, you can do live migration over hosts. CRIU is a counterpart for containers. Then I will describe example to make Bootstrap fast. When you have a heavier app in Bootstrap like JVM application like Jenkins or Redmine or legacy monolithic Rails apps, you may hesitate to reboot these apps even when it is required. For example, Jenkins requires 5 seconds to boot. Small letters, but this costs 4.8 seconds. I mean boot to listen on port 8080 using Docker Hub image Jenkins latest. This means it reads downtime more than 5 seconds when you have deployed apps to 2 solo containers. But if you have an ahead of time application process dump, CRIU can use this dumped image to restore the application in shorter time. It is often the case that script evaluation or language VM initialization accounts for a big part of the time lasting in Bootstrap. But CRIU can skip this kind of initialization process by dumping runtime memory state, which is already initialized and loaded with application code from existing process, and then restoring memory directly from the dump. Right one is evaluation, but left one is direct load. So I'm going to talk about more detailed examples. This is 2 bootstrap Ruby on Rails using CRIU from a dumped images. The company I'm working for have an application platform using containers like this. We have a web proxy in the front and forward accessed by virtual host. Using Nginx and Ruby for dynamically resolving backend containers. Users have each application's own host using containers to separate each user's environment. Users can deploy the apps into each container with least limitations. I'm describing more features of this platform in a rough language. In this platform, when one container host server is crashed, the new container with the same contents is automatically invoked in another host from the same image. Then redirect following requests to the new host. For users, it looks like that there is almost no downtime, even when one of the hosts is crashed. This architecture may make both users and operators so happy, but this architecture may make this architecture requires container application to be, of course, restarted. So I thought that we can or cannot manage this cumbersome reboot time to be reduced. So CRIU looked like a very good choice for this system. And then we have researched, I have researched this tool by investigating and comparing Ruby on Rails application restart time. First, I compared Ruby on Rails bootstrap time between using CRIU or not. In simpler local vagrant VMs, I'm going to describe steps to measure response time. First, I run requests continuously using benchmarkers, then plotted all of request time in each request. And while doing this, I forced to stop the target container hosting an application on purpose. On the next request, just after stop, the system requires a new container to be booted and then return the response from container in one request transaction. So whole response time at this point will be composed of bootstrap time and the real application response time. And then I'll show result. Right one is not using CRIU. Left one is using CRIU. This wall implies the restart. So using CRIU seems to be faster. Then I deployed simple Rails application to our platform. But not that this is staging. Run benchmarkers to the application and measured each rest time of responses. Invoke relocation between hosts. Relocation means move containers one to another. This is a picture. At first, I show the result of a relocation time wall overlay using Rails without CRIU. This is result. 8,000 milliseconds to be required. And then you also know we have a technology to reduce bootstrap time. It is bootsnap. So I measured bootsnap boot time using bootstrap. Here is the result, and then in this case it is 4,000 milliseconds to make boot. Okay, then I created CRIU image from this application in advance. Then I'll sync image between hosts. After this, the next host will use CRIU image to bootstrap a container. So this is the result using CRIU. This is the comparison. So the response time on relocation using CRIU will be reduced by 4x from application without any strategy. Reduced by 2x from just using bootsnap. So I got that CRIU is the fastest. In addition, CRIU is very effective to make scaling out containers faster. We can restore and spawn as many containers as we like, what we needed, from just one CRIU container image. CRIU spawning will be faster than from scratch, as you have seen. So this makes also scaling faster. The next section, I'm going to talk about my tool, Grenadine. Okay, as you have seen, CRIU is so effective for container bootstrapping. But I guess you are thinking, our application is deployed to VMs, not containers, right? Okay. Are you using containers? Really? Okay. Are you using VMs in production environment? Yes. More generally, migrating VM-based apps to containers is a hard way. Many aspects of system characteristics are varying between VMs and containers. For example, a VM has an init process. Daemons such as SSHD and rsyslog-d are full-stack file systems to manage full operation system. Containers are, in many cases, omitting these functionalities, such as application process as a PID1 inside the container, or no system management daemons, or simple and minimum and lightweight root file system. These differences will mess up developers to migrate applications. So, if there is a tool to help developers using VMs to get checkpoints easily and to restore their apps from the checkpoints, wouldn't it be helpful? So then, I wrote such tool, and I named it Grenadine. And I wrote it in mruby for RubyKaigi, not Rust. Let me show you how to create checkpoints via Grenadine. First of all, we must install Grenadine. I don't provide Grenadine's dev RPM or something useful to install. So I will use ahead of time build binary. And then I'm going to show movie. Okay. First, deploy your Rails application revision 1. Run this application via Grenadine daemon. So the Rails application is now up. Check it works using browser. Okay, then create a checkpoint of this Rails. Hit Grenadine dump and dumped. Listing checkpoints via Grenadine list. Now application is killed. So you can restore via Grenadine restore to in every timing you like. And Grenadine kill to stop. Okay, now let's deploy your Rails application revision 2. It's bundle install. and asset compile assets. Relink current. Okay, okay. Let's make daemon. Daemon. And then revision 2 is deployed. It is usual usual Rails application making dump. Thank you. Now we have two images. One, okay, one is revision 1, another one is revision 2. 0 is revision 2. We can choose any of the images to serve again. Restoration is in less than 1 second. So now I'm going to reserving application revision 1 again. Hit Grenadine from hash. Oh, I failed to do. Sorry again. Then we got revision 1 application again, and it just works. Working normal, usual revision-less application. Okay. Thank you. So I'm going to continue. This is Grenadine demo, and you can build Grenadine from GitHub repository. Now, okay. Next advanced topic is the internal of Grenadine. I'll show warning. Following talk is about Linux container runtime implementation. So you are required to have some of Linux kernel's container feature, such as Linux namespace, cgroup, change root or pivot root, and bind mounting, and so on. But please don't worry. I will show Ruby codes that implements container features. I guess you can read Ruby, so you can understand. Okay, indeed. Grenadine daemon creates a minimalistic container internally. So Grenadine is a kind of container runtimes. I have written 2 containers in mruby. You know Haconiwa and Grenadine. So I think mruby fits to create containers so much fitting. This is dummy code of how to write a container runtime or a containerized process using mruby. First, fork it first and isolate some attributes in forked process. Then invoke execve. It's better to wait PID in the parent. Okay. I'll dive into 2 container topics. First, one is that Grenadine unshares only PID namespace and mount namespace. CRIU is going to try restoring the same PIDs of each processes from dump. So in case of no PID isolation, with the when the PIDs are already reserved, already taken after created dump, restoration will be failed. We must unshare PID namespace. Unsharing PID makes process tree to start PID from 1 in each namespace. This avoids conflict. And managing proc file system working, multi namespace should be unshared. Here, this is a real Grenadine Ruby code, fair applicable, using clone system code to fork with a special flag. And indeed, fork exec wait is the basic of how to create Unix process. If you are interested in such system programming, working with Unix processes in Japanese, なるほど Unix process is a must. Next topic is that Grenadine requires no additional root file system. Grenadine creates ad hoc root file system using bind mount, sharing important directories such as tmp var log between an ad hoc new root and host root, and then pivot root into this new root. This is a real Grenadine Ruby code, fair applicable. In this code, I made temporary directory first and pivot root into this. I compose cloned version of host root using bind mount and so on. With these mechanisms, the processes Grenadine daemon creates look like a normal VM-based application daemon, but internally, some of attributes are unshared, and it makes CRIU to create checkpoints easily. So Grenadine is aimed that it can be introduced into historical VM-based applications with least changes. I'm going to talk about cloud native again. So now, all of you know about Ruby. All of you know that this is cloud native age. Now is the time everything becomes containerized, orchestrated, and microservice based. Rubyist can't avoid this stream. Grenadine is now. Grenadine can be used for historical VMs now, but I want developers and operators to use Grenadine as a checkpoint restore tool for Kubernetes or other container-based systems. And I aim Grenadine will be a cloud-native checkpoint restore middleware, like ones on CNCF. Now, current Grenadine have great chemistry with small applications, but soon it can be applied with larger and monolithic Rails applications, I hope. So please try Grenadine with your Rails or some applications. And I will release RPM or dev file as soon as possible. Then enjoy using next generation kernel features. Thank you. Any questions? 何分あります？ We have 5 minutes to answer questions. 日本語の方がちょっと嬉しいけど頑張ります。通訳の方はいないので。はい、オーガナイザーじゃん。じゃあ、オーガナイザーじゃない。
Grenadine is a very interesting product. I have a question. Do you have any plan of the running Grenadine on Mac OS like Docker for Mac OS or Docker for Windows?
You mean you want to use checkpoints using Docker via Mac?
Yeah.
Docker has already checkpoint feature in advanced mode, but it is very, very early version. So I have a friend maintaining Ranchy Docker. Suda-san said you can make pull requests to improve Docker. So I'm going to try in the future to make using Docker with checkpoints. Grenadine can be can introduce strategy pattern for normal VM or Docker or Kubernetes, I think. So both Docker and Grenadine will be changed in the future. という感じです。
Okay. Thanks.
日本語もいります？
とりあえず言っておきましょうか。
はい、まあ、要するに、Docker にもチェックポイントリストの機能はすでにあるんですけど、かなりアーリーバージョンで、あまり実でもないので、知人の Docker のメンテナの人に、君が作ればいいじゃんみたいなこと言われたんですけど、そうです。はい。はいという感想でした。で、グレナデンはもうちょいストラテジーモードというか設計を整理して、普通の VM にも Docker にも使うみたいなパターンは入れたいとは思っているという感じで、はい、です。
はい、ありがとうございます。
Any question? You can ask me outside this hall. はい。まあ、この発表の後で質問してもらっても大丈夫です。ということで、ありがとうございました。Thank you! Enjoy Fukuoka!